Today we discuss the article basis of a solution space of a homogeneous system. So this is a very important article in the linear algebra. So let us start with to find out the basis of solution space of homogeneous system of linear equation. So one by one we discuss that how we can find out the basis of a solution space of a homogeneous system of linear equation. For that we have to consider the homogeneous system of linear equation. Okay, homogeneous system of linear equation means it is a set of linear equation. Okay, so if you can consider the one linear equation, consider one linear equation in two variable, say x and y. For example, x plus 2y is equal to 3. So this is the equation, and that equation contains two variables, x and y. The power of this variable is 1, therefore maximum power is 1, therefore this is a linear equation in two variable. Okay, if you can consider the another equation, so 2x minus 3y is equal to 0. So this equation is also a linear equation in two variable. So there are more than one equations are there, therefore such a set of linear equation is known as system of linear equation. Okay, now if such a system is given to you, okay, then the system of linear equation has two types. One is a homogeneous and other is non-homogeneous system. How to identify the system? So see the right side constant of this equation. The right side constant of these equations are non-zero because 3 is a non-zero term. Therefore this system is a non-homogeneous system. So how we can write the homogeneous system of linear equation? Only the right side constant should be 0. For example, if you write x plus 2y is equal to 0 here, and this is 2x minus 3y is equal to 0. If we observe that both equations, left side of the both equations are same, but the right side of this equation now we can take 0, 0. Okay, then such a system is called as a homogeneous system of linear equation. And once your system is homogeneous, then we have to find out the solution space of homogeneous system. And once you find out the whole solution space, then we find out the basis. So what is the procedure to find out the solution of this homogeneous system? So first step is that consider this system in a matrix notation, matrix form. Okay, we convert this in a matrix form. Okay, matrix form means construct the matrix here in this way. So the first equation, there are two variables are there. Just we collect the coefficient of the variable in the first equation. The coefficient of x is 1, coefficient of y is 2. This 1 and 2 you write in a first row of this matrix. Similarly, the second row of this matrix is nothing but the coefficient of x and y in the second equation, that is 2 and minus 3. The variable x and y we write in a column wise. So the right side of this system of linear equation is 0, 0. Therefore this right side matrix is 0, 0. So this system we write as a matrix form. So the entries in this matrix are the coefficient of the variables in each equation. Therefore this matrix is called as a coefficient matrix. This is a variable matrix because the variables are there, and these are the right side constant of that equation. Therefore this is a constant matrix. So we give some name of that to that matrix. So this matrix we called as a capital A, this matrix is X, and this is a 0 matrix. So this is a Ax equal to 0. So any system of linear equation we convert into a matrix form. Later on, we have to find solution. To find its solution. Okay, and once you find out the solution, there are different methods are available, but we use the Gauss elimination method to find solution. Gauss elimination method to find out the solution of the system of linear equation. Once we apply the Gauss elimination method, we get the solution, and solution is nothing but the value of x, and that x satisfies x equal to 0. Okay, and if we write all the solution in a set, okay, such that x equal to 0, then such a set is called as a solution set of a homogeneous system. Clear? So let's we consider the another example, and then we find out the basis of a solution space of homogeneous system. So here the question is, find the basis of solution space of homogeneous system homogeneous system 3x1 plus x2 plus x3 plus x4 equal to 0, 5x1 minus x2 plus x3 minus x4 is equal to 0. Consider this example, homogeneous system. Now we want to find the basis. It is enough to first find out the solution. So first step is that, step 1, write the system into matrix form. Okay, so the matrix form is here. First is the coefficient matrix. We write all the coefficient of this variable in the first equation, that is 3, 1, 1, 1. In the second, 5 minus 1, 1 minus 1. 5 minus 1, 1 minus 1. We write here the variables x1, x2, x3, x4, which is equal to 0, 0. Okay, so this is x equal to 0. Now consider augmented matrix. Consider augmented matrix. Augmented matrix means a matrix, one more column is insert, that is 0. So this is 0 means we take this column is inserted to the A. So this is 3, 1, 1, 5 minus 1, 1 minus 1, and here partition, this is 0. Now use elementary row operations. Use elementary row operations on the augmented matrix A0, so that this matrix is reduced to row echelon form. Okay, so how to convert into the row echelon form? First, I multiply this first row by 2. So 2 times R1, because it becomes a 6. If we multiply this first row by 2, so the elements are 6, 2, 2, 2, 0. Second row is as it is, 5 minus 1, 1 minus 1, 0. Okay. Now we want to convert this entry is 1 leading element. So what we do? Use R1 minus R2. So use R1 minus R2 operation. So the matrix is reduced to the new matrix. 6 minus 5, 1, 2 minus of minus 1. So we write here 2 minus of minus 1, that is 3, 2 minus 1 is 1. Similarly, 2 minus of minus 1 is 3. And 0 minus 0 is 0. The second row is as it is. 5 minus 1, 1 minus 1, 0. Now, this is the leading element. Now, our next aim is that convert this element is 0. By using the operation, so we multiply the first row by 5. Then use the operation R2 minus 5 times R1. R2 minus 5 times R1. So 5 minus 5, then this entry becomes 0. Let us see. The new matrix is here. First row is 1, 3, 1, 3, 0. Now, first row is multiplied by 5 and subtract from R2. 5 minus 5 is 0. 5 into 3, 15. Minus 1, minus 15. Minus 16. 5 into 1, 5. 1 minus 5. Minus 4. 5 into 3, 15. Minus 1 minus 15 is minus 16. And 5 into 0 is 0. 0 minus 0 is 0. So this is the leading element 1. This one is 0. Now we make this element is 1. Leading element. So I use the operation minus 1 by 16 times R2. So the new matrix here, right? 1, 3, 1, 3, 0, 0. This is 1 minus 4 upon minus 16 is 1 by 4. This is 1 and this one is 0. Now convert this matrix to the equation. So this is x1 plus 3x2 plus x3 plus 3x4 is equal to 0. Next one is 0x1, that is only x2, that is x2 plus 1 by 4 times x3 plus x4 is equal to 0. If we observe that there are two equations but there are 4 variables are there. Number of variables is 4 is greater than number of equations, which is equal to 2. And whenever the number of variable is greater than number of equation, system has free or independent variable. System has independent variable. But how many independent variables are there? Total there are 4 variables. So if we take the subtraction 4 minus 2, so 4 minus 2 is equal to 2. So the system has 2 free variable. Free variable means the variable takes any real number. There is no restriction. But how to identify which variable is a free variable? So if you observe that row echelon form, so the first column has a leading 1 here, the second column has a leading 1, the third column do not have a leading 1, the fourth do not have a leading 1. So corresponding variable is x3 and x4 we treat as a free variable. So let x3 is equal to say A and x4 is equal to B are independent or say free variable. It takes any real number. So I call as a one equation here. This is equation 2. So we put the value of x3 and x4 here. We calculate x2. So from equation number 2, we can calculate x2. So this is x2 plus 1 by 4 x3, but x3 is A, plus x4 is B equal to 0. So after calculating, x2 is equal to B minus 1 by 4 A. So this is the value of x2. Similarly, we calculate the value of x1. So from equation number 1, we can calculate the value of x1. So from 1, x1 plus 3 x2, but x2 is B minus, so here plus B is right converted to here, this one minus B and minus 1 by 4 minus A. So this is minus B minus 1 by 4 A. Clear? Next, x3 plus x3 is A. plus 3x4 plus 3. x4 is b equal to 0. So we simplify and then find the value of x1. x1 minus 3b minus 3 by 4 a plus 3b equal to 0. So x1. So how many a are here? So this one is minus 3 by 4 and this one is a. So 1 by 4a plus 1 by 4a and minus 3b and plus 3b is cancelled. So which is equal to 0. So x1 is equal to minus 1 by 4 times a. So we get all the values x1, x2, x3, x4. Okay. Hence we write the solution in a systematic way. Therefore, solution x. Solution means the value of x1, x2, x3, x4. x1 is, here we calculate, x1 is minus 1 by 4a, minus 1 by 4a. x2 is minus b minus 1 by 4a. x3 is a, x4 is b. So this is the solution, and this solution we split as some terms of a and terms of b. So here minus 1 by 4a here. Now we write here minus 1 by 4a. Next one is we write a here. There is no a, so we write 0. Plus we write all the terms of b. There is no b here, so write 0. There is a term b is minus b. There is no b, so we write 0. And there is a term is b. Okay. So x is equal to, so here we take the minus 1 by 4 is outside. So there is a term is, so what, we also take the a is outside. Okay. So minus a by 4 we can take it outside. So we get the 1 here. So we get the 1 here. And a is outside, but minus 1 by 4 is the coefficient. So multiply by minus 4. So this is 0 here. Similarly, minus b. So you take the plus b is outside. So we get the 0, minus 1, 0 and 1. Okay. So this is the solution of that homogeneous system. Now this solution is the linear combination of these two vectors. Means these two vectors spans the solution space. So this vector 1, 1, minus 4, 0 and 0, minus 1, 0, 1 spans the solution space, and these vectors are independent. These vectors are independent, that is linearly independent. Therefore, these two vectors are the basis. Therefore, basis of solution space of homogeneous system x equal to 0 is the set that contains the two vector 1, 1, minus 4, 0 and second is 0, minus 1, 0, 1. These two vectors are the basis of the solution space. Why the basis? Because when we can consider the example here, homogeneous system, and we want to find out the basis of a solution space, first we solve this system of linear equation by Gauss elimination. First we write the augmented matrix form, then we write the augmented matrix. We reduce this matrix to the row echelon form, and its row echelon form is here in this way. Here later on we can convert into equation, identify the free variables. So if there are two free variables, then we choose x3 and x4 are the free variables. So free means it takes any real number. So we assign x3 is A, x4 is B. Then we put these x3 and x4, the values in the equation 1 and 2. So we find the value of x2 and x1. Then we write the solution set. X is x1, x2, x3, x4 is in this way. We split this vector into addition of the two vector. So these are the terms of A, these are the terms of B. We take the minus 1 by 4, A is outside. So we get a 1, 1. Here A is outside, but the coefficient is minus 1 by 4. So multiply by minus 4, 0. And here we take the B is outside, 0, minus 1, 0, 1. So any vector in the solution set is expressed as a linear combination, that is k1 into 1 form vector plus k2 into this. So any vector, if you write as a linear combination of these, therefore these two vectors spans the solution space and they are independent. Therefore these two vectors are nothing but the basis of the solution space of a homogeneous system. Now once we find out the basis, then the next very important is dimension of a solution space. Dimension of a solution space. Dimension is the word is related to the number. Once you find out the basis, you just count the number of vector in the basis set. So here basis contains the 2 and the number of vector is nothing but the dimension. So dimension of the solution space is number of vectors in basis of solution space of x equal to 0. So here the number of vector is 2. Therefore the dimension of the solution space is 2. And the dimension of the solution space is also known as nullity of a matrix. Okay. So student, I hope that you understand the concept of the system of linear equation, how to solve, how to split the vector, identify the independent vector, and if that independent vector forms a basis. Thank you very much.